It's a privilege for me to be here and speak on this forum. And I thank the organizers for giving EIL the opportunity to bring our views into what operational excellence means to us as consultants, and also share our experience as to what minor details need to be addressed right from design stage on to the project management, implementation, and operations to ensure that whatever investments have been done meet the expectation of the owner, the intent of design and purpose, and if possible, exceed their performance to bring value to the organization. So let me just give you an overview as to where India is. I'm sure this has been spoken earlier. But in terms of energy needs, we need to invest a lot either on energy sources from within the nation or imported energy sources. And the growth of the nation, which is expected in years to come, is the highest in terms of the averages of the world. So in terms of the insufficient endowments which are there within the country, wherein adoption of new technology, import dependency, turning to cheaper supply of energies, ensuring that everybody has affordable energy, and all the other factors that are here, is essential that the growth and the investment is a certainty. And therefore, the topic which is there for this particular conference, which looks at operational excellence and looks at reliability innovation, is extremely pertinent. So I'll straight away go to the process safety, and I'll touch upon some elements which we encounter while we do the basic designs, some elements which we would like that the industry adopts as a whole in project management, and of course the intervention of digitalization, how we think in a stepwise manner will change the landscape of the industry. So if you see the process safety management, and since this particular section is about asset management per se, we have these four basic pillars on which the process safety management stands. One is the commitment from all the stakeholders on process safety. This is culturally required to be there in the organization. There has to be competencies within the organization to follow these process safety standards, and therefore involvement of all is necessary, right from concept to commissioning and subsequent operations. For actually building this system, we need to understand what are the risks involved. So a lot of knowledge base goes into what we are handling, how we do the designs, how we look at it in terms of risk identification, risk analysis, hazard, and so many other steps that are involved to actually build a robust system. The third, and where we will take this forward, is managing the risks involved in the operations, in the work environment, the asset integrity, which we'll talk in more detail, and the other elements. And most importantly, how we are putting back that knowledge and experience into the system. And that is a very, very essential pillar, is learning from what we experience. So with that, the two things that we would look at in more detail is about the asset integrity and reliability, and also see what is the management review process and how it becomes a continuous improvement into the systems and procedures. So if we look at management integrity, asset integrity management in an overall view, we have the integrity management approach which has to be in place. Extremely important how you do the project quality management. And often our experience has been that while there is something in paper, but there is actually certain different situation when we are at site. How to bridge the gap between the two, how to bridge the gap between the design table and the actual plant. Look at reliability and maintenance management. We heard a while back about the maintenance aspects, and more the industry is shifting towards predictive maintenance employing smart equipment, smart processes. Another critical element is how to look at corrosion, and we often see there is considerable downtime when these issues are not addressed at the design stage. And as we go along and the process changes occur, how these impact of process changes, of operational changes, are actually analyzed by management into an integrity of an asset. And of course, the regular feature of inspection management. So any asset integrity program has essentially 5 key things to be looked at. The first and foremost, that the equipment and systems are designed, well fabricated, and installed well. And we have had experience, and I'm sure the audience who is from the industry, when we do a design and when we do a fabrication and do an inspection, and the equipment is installed at site, you may find that the design was right, the fabrication was wrong at one place, or the inspection was wrong, or some mismanagement of materials, etc., have taken place. So this whole program completes to look at the gamut of all these elements. Another important factor is the unit is operated within the design limits of the equipment. How unsafe we are, and here we have an example. Some years ago, we have a gas company, and there was some aberration in the operations leading to some failures, and it was found that they were exceeding the design limits. So it's very important whether you, because the asset also loses its value, and the life decreases as we go along. The techniques of inspection, test, preventive maintenance, they are also conducted by trained and qualified individuals. Approval of processes and procedures is extremely important at all steps. Repair work, maintenance, repair work also following the design codes, following manufacturers' recommendations. Several times we have equipments which have failed, but we don't have the manufacturer's recommendation, and we do a quick fix, and they lead to problems later. And how these deficiencies, how they are discovered, what is the processes to find out that this is the corrective action needed. All this encompasses the elements of a complete asset integrity program. And I have some aspects of process design being from a core process design team. There are some musts for any processes, any idea, any development to actually lead to a commercial success. And this comes from the knowledge and experience of several design elements. We have in EIL a strong team who looks at the design aspect right from the lab stage or bench scale up to a mega plant or a commercial scale, world scale state-of-the-art plants. So first and foremost, it must meet the objective of yields, quality, capacity. It should conform to all the norms, follow the best practices, have a robust process control scheme, ensure safety, operations, maintenance, and project implementation. The last one is particularly important. Several times the designer is unable to conceive or perceive how the physical site is, how the equipments should flow, how the sizing has to be done, how to split the equipments, and you lead into a lot of project implementation issues, or what are the commercial equipments available. So all these aspects have to be dovetailed with the basic design of a process. The second aspect is, how do you decide, how do you optimize a process design? It is a good thing that we can make heavy investment at the cost of bringing more reliability. So what is the balance between a capex and a reliability? How do you spare it? How do you make redundancy? So if you have a requirement of an uptime of 330 days or 300 days, depending on industry to industry, how do you design this? And the third point is, what is the minimum that you need for process control and operability? And the last but not the least is safety. So whenever the process diagrams, instrumentation diagrams, PNIDs are developed, and the process design per se is done, these are all the factors that have to be weighed on case-to-case basis. And there are several new processes. When we do, these become more and more important, even in newer areas. Like today we are looking at areas of biofuels. What are the elements of safety that that particular industry requires? Whether is it as stringent as a hydrocarbon industry? Can we waive some? Can we bring down the cost? So these are all the issues which go into as you move from industry to industry. I would just share two systemic and instrumentation driven elements which will help in times to come. Some of these are already implemented, and some the industry would have to adopt, one of which is the use of the tools for dynamic simulation. This has been there for some time in the industry. It's a tedious exercise to do, to assess built in each and every hardware into the simulation to see how the system will behave. But it is very, very relevant as we go along and we see the growth in the refining industry, in the petrochemical industry, more in the refining industry, wherein we have to maximize assets. How would they behave on a real-time basis? We all do designs on a steady state, but it's essential that to assess the integrity, we look at these projects. And why we need to look at dynamic simulation is that when we add a investment in a steady state kind of condition, we just add a parallel equipment to meet the differential capacity. But in a dynamic simulation, you may not need to add an equivalent to the capacity that you add, particularly in flare systems, which are extremely expensive, very difficult to install. You have several line sizes of 100 inches and more than 100 inches, and the trestles that you have to build all the way in the offsites. So what is it that this existing asset can safely handle for brownfield expansion? And it also can give you a predictive analysis and a failure analysis. So this particular tool is a emerging tool which will have to be deployed in the sector, particularly in the hydrocarbon sector, to see how to look at assets. And the second aspect is instrumentation. More and more dependency on instrumentation. In offshore designs, these were already there. In pipeline designs, these were already relied on. It is more and more migrating into the process industry, wherein instrumentated shutdowns are considered reliable for the operability and safe shutdown, and you don't need to invest in a superior metallurgy or have a redundancy built in. So broadly, these are the three aspects of process design areas which are pertinent to making sure that your asset is managed well, it is integral, and it is safe. Materials. This is an input which goes into process design, but it has a very critical role. Several times this is picked from a standard, but the future, how the, let's say, the H2S content of a gas field will go, or what is it that if you change the, the wash water, how would a particular exchanger metallurgy behave, or the real feedback as to actual process streams from a refinery going back into a added design. So it is essential that materials are addressed at a very initial stage, critically evaluated and selected. The second part, the first part was on looking at process design elements, including the material selection. The second part is how would you look at project management. And project management in today's time, when we are managing mega projects, it is an extremely difficult, challenging, arduous task for a site in charge or the project manager to manage the whole inventory and see how the the implementation is done. So devices like RFID we have started installing in several of our fittings, particularly helps in warehousing, personal tracking, badges, ultrasonic IDs, video tracking, GPS tracking, barcoding, and ultimately a virtual reality training toolkit. So these are elements which are finding more and more in place into the project management aspects. Quickly look at room wherein we know that, I think most of us would have experienced that when we go to an inspection workshop and we actually hydrotest a vessel or an equipment, several times it fails there. It fails because the skills of the welders are not up to the mark. They may be certified, but they have their own issues in terms of the mismatch between a paper and actual value. So when we look at implementation, we look at construction activities, processes, moving from a virtual twin of a process plant, it would also play a very important role in construction, in the fabrication of equipment. How do we look at digitalization? Now, we'll kind of stagger it, or we could make it stepwise into three broad steps. So we have seen earlier presentations how digitalization is kind of becoming an element in almost every activity and every aspect, every presentations that happen. Now, the first thing is we have a set of operating data which is there, which is installed, it is operating. First thing is to make it smart, connect the sensors, monitor it, collate the data, and make that a big data. So first thing is to maximize the utilization with minimum investment onto what the assets we already have. And I'm happy to share with you, EIL has some softwares, proprietary softwares, where we look at data reconciliation and doing some real-time measurements. Then next step is to move to cloud-based analytics. Move that to cloud computing, generate bigger data, look at the reporting, the visualization, so enhance the data to the next scale. And as we move forward and we forecast the future, we move more and more into AI, wherein we are talking of digital twins, we are looking at anomalies in operations, and the remote management of assets, and look at supporting the O&M of a refinery or an asset by using the AI techniques. And ultimately, the fourth generation environment of refining and the industry, which is in times to come going to be a reality. So with that, I will look at the asset management, and when we saw the first pillars, the 4 pillars, there was this part of the leadership policy and strategy. And while there would be people who would actually make it happen on the field, the line managers, the workforce, but this we believe, and I personally believe too, that this is more of a leadership and a policy issue. So it has to be a top-driven kind of approach which is instilled into the culture of the organization, understood and instilled. How you would manage an asset, what are your objectives, how the asset meets the management objectives, the processes, procedures, knowledge, to build the capability of asset management, and you have a value delivery. So it has to be driven from the top down. But the people at large have to also follow something which is equally important. And that, I would say, is what the theme is: the reliability, innovation, and excellence. We are very good at implementing something, but often we sort of slip in making things or making our experience a system. So it is extremely important to systemize it. And anything we don't systemize loses, in a document, in a file, and it's just lost. It doesn't come back to enrich any of the elements, be it design, be it operation, be it management, anything. So this is something which I would leave, with, is that follow the classical Deming approach: plan, document it, define the requirement, objective, whatever are the regulatory practices, industry practices, do it, implement the system, check whether the implemented system has actually served the purpose that it was set up to, and as required, have a management review, set the improvement objectives, and monitor what is the gap, what you actually set out for, and what was the ultimate objective. And most importantly, make that a standard for the company, standard for the system. And once we do this, we are moving towards achieving the objective, achieving the theme, and moving towards more reliability, innovation, and excellence at large in the industry. So thank you very much for your attention.